Hello and welcome back. So in this tutorial we'll be looking at another type of question based on trigonometric ratio of multiple angles. So here is our question, and for this question I'm going to take the right hand side of the equation because it's easy to simplify this bulky part than to add for these small simpler side. So simply, I'm going to take the right hand side of the equation and try to get 2 cos A as my left hand side. So here is my right hand side, and now I'm going to use the formula for cos 16A. So cos 16A can be interpreted as cos 2 times 8A. So we have the formula for cos 2A, which is equal to 2 cos square A minus 1. We need cos 2A in terms of cos, so we should write this formula, otherwise we have to use this formula instead. So let me substitute the same formula over there, 2, and then once again root 2, once again root 2 plus 2, so cos 16a, which is cos 2 times 8a, is equal to 2 cos square 8a minus 1. I've applied the same formula here, so root 2, and then root 2 plus 2 times 2 is 4 cos squared 8a, and then 2 times negative 1 is negative 2. I can cancel the positive and negative 2. So what I have is 4 cos squared 8a inside the root. So 4 cos squared 8a can be written as 2 and cos 8a and then whole squared under the root. So these two terms get cancelled and we have 2 cos 8a simply. So root 2 first, and then another root 2, and then another root 2 plus, and then we have 2 cos 8a. Here we have to use the same formula over and over again. So for this cos 8a, we can interpret it as cos 2 times 4a. So once again we have to use the formula for cos 2a. So 2 first, and then 2, and then once again 2 plus cos 8a. Cos 8a is equal to 2 cos squared 4a minus 1. So on further simplification, what we get is 2 plus 2 times 2 is 4 cos squared 4a, and 2 times negative 1 is negative 2. These two terms get cancelled, and for this 4 cos squared 4a, we have 2 cos 4a, and then it's whole squared under the root, so these two terms get cancelled out, and we have 2 plus, and then root 2 plus, and then this term 2 cos 4a over here. Now once again, same formula for cos 4a, we have to interpret as cos 2 times 2a. So here what we can do is we have 2 here and 2. Then for this cos 4a, we can write 2 cos squared 2a and then minus 1. So on distribution, what we have is 2 plus 2 times 2 is 4 cos squared 2a, and then 2 times minus 1 is negative 2. These two terms get cancelled once again, and we have 2 plus, and then for this 4 cos squared 2a inside the root, we can simply write 2 cos 2a instead. Once again, what we can do is we can apply the same formula for cos 2a here. So we have root 2 plus 2, and then cos 2a is 2 cos squared a minus 1, and then we have 2 plus 2 times 2 is 4 cos squared a, and then 2 times negative 1 is negative 2. These two terms get cancelled, and under the root we have 4 cos squared a, and it can be interpreted as 2 cos a, and then it's whole square. These two terms get cancelled, so finally we have 2 cos a, which is our left hand side of the equation. So we have proved this question. I hope you got the concept. If you have any confusion, you can mention it in comment section, and yes, thanks for watching.